Okay, for today we are starting off, this is the second day on sinusoidals, where we're going to basically be writing equations for the sinusoid and factoring in shifts. That's what we didn't do yesterday. But I'm going to start the hour here by having you graph this one, 4 cosine of 5 theta, and then after that we'll change it to secant. All right, so now after you've graphed this, hopefully you notice that this changed all of my numbers, but I had to multiply them all by 1/5 here. And then I'm going to ask you to now graph secant of, or 4 secant of 5 theta. And that's going to cause the graph to look completely different. I'll give you a second to do that. All right, so to do secant, we would have asymptotes here. Why do we have an asymptote there and there? Because cosine hit what? 0. And if we're going to graph something that's 1 over cosine, then 1 over 0 is a bad thing. So there's asymptotes there. So then your actual secant graph is all this red. And it goes this way and that way. Raise your hand if you had that one right. Good. And then if I had changed the problem one more time and thrown in a negative right there, now it's going to be tough for a lot of kids spatially to understand how to do a reflection the correct way to get your final answer in the right spot. I'll pause for a second while you try that. Okay, we're back, and what do you do with that negative? Well, this loop that's on the bottom here now needs to go up here, and this loop that's on the top here needs to move and go down here, still heading towards the asymptote. And then this last one, this one here, needs to not be there and instead needs to be going here. So I will kind of highlight them. This is the final answer then. Hold on, get my highlighter pen out. This one, that one, and that one. Now, one thing I did not actually do technically right, and I want to call your attention to it. It's a small thing, but if this is really supposed to be 1 over the function, when the function was 4 right here, shouldn't my new function be 1 over 4 and therefore only go to 1/4? All right, so this should have been down here looping up. And this loop here, that again, this was -4 right here. The new function is 1 over that. 1 over -4 is -1/4. So this actually should have been up here. So when we flipped it, it should have been lower. Should have been there. So I wasn't being careful on this one. This should have been lower again because that's a spot where it's 4. So the new function is 1 over that, or 1/4. And then again, this should be lower. All right. Now that that's fixed, yes?
Do you do translations first or reflections?
Good question. So these problems should generally be done as long as you do the outside and get the whole outside done, and then go do the inside, or do all the inside stuff and then do the outside stuff. So the answer isn't as simple as always do your stretches before your flips. It's about the inside and the outside. Would you agree that this is considered on the inside? Since there's only one thing on the inside, you just have to do that one thing. And I recommend you actually start on the inside and do that first. That was the renumbering part. Then you move to the outside, and technically there's 2 things. I find it easier to do your reflections last. Get your graph all done, and then if there's a flip to be done, get it all done and then flip it. Yes? Yeah, look at how messy that is. Absolutely. The only thing that's actually the answer here is these highlighted ones, which I haven't fixed this one yet, but only those highlighted ones should be left.
Why would it be?
All right. Would you agree that the original function was 4 here because of that 4 right there?
Yep.
Okay. Then 1 over that function at that moment where the height or the y value was 4, the new value has to be 1 over that.
Why?
Because these are reciprocal functions. Sine is 1 over cosine, right? or in this case, cosine, sorry, not 1 over cosine, 1 over cosecant, all right? In this case, for this one, it's the secant is really 1 over the cosine function. That comes right off the sheet. That's what you're doing. I know some of you are just got used to like, well, okay, so it rides on the parent function's back, so it goes like this, and then there's loops. See, like this. You didn't really know what you were doing. What you were doing is taking this value, which happened to be 1 before, and then do you get if you flip 1, you still have 1? Okay. And this value, which was -1, and when you again flipped it, the reciprocal, the green one, is still the same, because 1 over -1 is still -1. But what if this had been a 4? Well then, the new function should be not 4. This green one is supposed to be 1 over what the old function was, so it should be down here. All right. I know I never showed you that before because we always had a 1 here when we did it. All right. Yes. It's changing it to secant, change the inside. Give me an example problem. Y equals 4 secant of 5 theta. You get your own question answered? All right. Okay. So, what do we do next? Well, when we left off, we had just showed you about how if I give you the graph, the important 2 spots are the high spot and the low spot, right? From that high spot and low spot, you were supposed to be able to make an equation for that. And it's really kind of cool if you think about it. If you've got a wave and you've got 1 high spot and 1 low spot, that's all you need to be able to write a complicated sine equation to get that wave. That wave that'll keep going up and down, up and down, up and down, up and down. So, I think the best way to review that is we're going to grade last night's homework, one of which was a problem like that, and I'll go through that thoroughly with you. So, I know some of you didn't do that awesome on that problem, but you're only going to lose a couple of half points out of 10. You obviously won't have it. All right, so right now take out your green worksheet. Okay, so only one of these off the worksheet that I want to talk about on the video today, and that is this one. So as you're grading this, look for the high spot was supposed to be here, and the low spot was supposed to be here. Now, I hadn't taught you yet about how to handle the fact that this is a shift where here's your X and your Y axis, and it's been shifted to the right. Now, we're going to talk about that later, but for right now, I'm just going to be talking without a shift of what you should have had. So it always starts with Y equals, and I'm going to recommend that from now on you use cosine. Okay, so my high spot and my low spot, how do I use those to get the equation? Well, the first thing I told you was find the line that runs right down the middle. Okay, so that it ends up looking something like that with that line down the middle. Where was the line down the middle? It's the average of these two. The line of symmetry that runs down the middle of these functions, that's what I'm calling it for now, is at, what is 13 and 8 average to? 10.5. Why is that such an important line? Because it tells you how far up the whole thing got shifted, 10.5. And it tells you how much the amplitude is. And that's between 10.5 and 13, which is 2.5. So they should have said 2.5. And I would recommend from now on using cosine, but they could have said sine because at this point I hadn't taught you guys about shifts yet. Okay, but from now on, use cosine. I'll show you why in a minute. Then it was shifted up 10.5. That's worth half a point for this, the 10.5 there, half a point for having 2.5 here. And the last half a point is the hardest part of it all, which is this. That B term. We have a formula for figuring that out. Period is 2 pi. Period is 2 pi over B. Now, did I tell you B? No. Can I figure out this thing's period? Yes, I can. So I'm going to put it right here. But its period comes from how long, sorry, how long does it take for this thing to finish a complete cycle? Well, first off, that's only half a cycle. But how long was it from here to here? Well, that is the x's subtracted. So you subtract 5 pi over 6 minus 1 pi over 6 gives me 4 pi over 6. Could I reduce that? Yep. And it would be 2 pi over 3. Now wait, that is not the period of this thing. It only went from the high spot to the low spot. If it only went halfway, stop clicking. Thank you. If it only went halfway, then we have to double it. So double the 2 pi over 3, what do you get? 4 pi over 3. That's this thing's period, 4 pi over 3. All right, and we're still not done. Holy cow. 4 pi over 3 equals 2 pi over b. That's the formula with 4 pi over 3 plugged in. Now I'm going to cross multiply. B times the 4 pi is 4 pi b, and 3 times the 2 pi is 6 pi, and then I'm going to divide both sides by 4 pi. That's close, but I got to simplify it. Cancel 6 over 4. Crazy today out there. Okay, what's 6 over 4 reduced to? 3 over 2. That's what should have been here. I'm curious, how many kids actually got that figured out? All right. Well, that's how many kids are going to get A on this next test. Unless you just got it from my explanation I just showed you. No, you should learn how to do this. And the test is on Thursday. So don't interrupt me, please. Yes? Okay, no, because we use this little formula, period equals 2 pi over b, to find that 3 over 2. Now, I know what you're thinking of the easy ones. On the easy, unless I did, let me just double check it to make sure I didn't screw something up here. 4 pi b equals 2 pi times 3 is 6 pi. 6 over is 3 over 2. Nope, this is correct. And you have something to add? And it's okay for them to have used sine. That's okay. That's not a problem. As I said, I'm going to tell you from now on use cosine because I have one more piece to add. But what you're thinking of is if I knew this period here was like 6 pi, some simpler number, it wasn't a fraction, okay, then you can usually just do 1 over that number. That usually works. But when the period comes out to something icky, like it did in our case, our period was 4 pi over 3. It's not so simple as just flipping them over. Okay, so anyway, bottom line, I have double checked it, and I had it last hour too, and the hour before that, and I'm 98% sure that we got the correct number here of 3 over 2. Let me just see one more time. Who are the people who had the answer of 3 over 2? All right, and those are some top students, so I'm thinking it's probably right. If you can prove to me later that I'm wrong, I'd like to know it, but I'm going with that for my answer. All right, so now one more thing. If you're really smart, you notice that this can't actually be right. The thing I haven't been talking about. What did we not do? A shift. All right, but do you get cosine? If it really was going to be cosine, then this spot should be over here. The high spot of cosine hits right at the y-axis, and it's not. It's like it's been shifted over that far. So all you got to do is say, how far is that peak from the y-axis? It's, a second, for extra emphasis, it's right here. That's how far over it's been shifted. So the actual, and this is what you're responsible for from now on, is you use cosine, because then you can just tell that the peak of cosine should be here, and it's that far off, and you say then that your shift should be right. It'll always be to the right because we're always going to pick cosine, which will have a peak somewhere to the right of the y-axis. And it'll always be this distance, which will always be the x value goes in there minus pi over 6. This is still plus 10.5. All right, that was some hardcore pre-calc. I know some of you are still skeptical, but if I was going to sum it up to one thing, the only thing that's different from yesterday is this highlighted part where the x value of that peak, if you use cosine, all you got to do is put this comes from here and it goes over and goes in right there. That's it. It's got to be shifted to the right that far. Yes, sir. What if it was sine? Then I'd say you didn't listen because I said always use cosine. Okay, now I know, and I told you yesterday, we're starting with just doing sine because they're called sinusoidals and it's simpler because everything can boil down to sine. But I know sometimes you're going to look at a function and you're going to say, well, I'd rather have it be sine. It can still work to have it be cosine. Even though this looks, Mr. Server, it's starting at, oh wait, that wouldn't be sine. Wait a minute, let me slide this over. There. If you were even good enough to know that, okay, that looks like it should be a sine graph instead of a cosine graph, do you get, I can still say, ooh, I'm going to call it a cosine graph that's been shifted that far. Because if I go over here, now that's what cosine looks like. It always starts at 1. And now it's been shifted over that far. So if you just always use cosine, it'll work. All right. So imagine for a moment, you've got a wave. We'll do a simple one. It's a sine wave. I'd still say you should write it as cosine. It's cosine that's been shifted over, well, however far that is. So classic sine can actually be written as cosine. Would you please do that right now? This was sine, but I want you to write it as a cosine. I'm going to pause for a second while you give that a try. So when I said it was classic sine, I meant that this height is 1, this height is negative 1. It goes all the way to 2 pi. And that is sine, but do you get, I could write it as cosine with a shift. How much of a shift should it have? That spot's x value, and the x is down here, minus pi over 2. Now, could you shift it to the left also? Yeah, but it would be more complicated. It wouldn't be left pi over 2. It would be left further. You could make this as a shift to the left, but it would be more complicated. All right. So now let's see. I'm going to make your life a little better today because we're going to clean up the x values on these so that it's simpler. Here's a spot, 2, 3. Here's a spot. It's the high spot, and it's going to be at 8, 12. Look at that. No more like 4 pi over 3s and all that kind of complicated stuff. But isn't it kind of cool that I could say if that's the low spot and the high spot of a wave, you can write the equation for it now. Remember I said always use cosine. And then you'll be able to do what we just talked about and put in a shift. You need to tell me what's the A, what's the B, what's the C, which is the shift, and what's the D. All right, give it a shot. You got a partner and a brain. Use them. For the groups that are stuck, I had suggested that this line that runs right down the middle, and thus, you know, this can be thought of like this. That's a terrible sine curve, but anyway, that line that runs down the middle, whoop, rats, there we go, is super important, and it's the average of 3 and 12, which add up to 15, and therefore half of 15 is what? 7.5. How many of you are using 7.5 in your calculations? Excellent. Then, if there is a wave that's going down here and then up here, then this distance is important too. Well, it's going from 7.5 up to 12, and therefore, what's the amplitude? I think it's 4.5. All right. So 4.5 should be in your equation. 4.5 goes in front because it's the amplitude. All right. And this is cosine of, and then I need a shift in here, minus, I said it would always be right, the first peak that you got, the x value of that, which is right there, the 8, who had a minus 8 inside their parenthesis. Good, that's the right answer. If you didn't catch that, you find the first peak, and then you say, how far is that from where it should be? And where it should be is like back here. This peak, if it's going to be cosine, should be over here. And how far away is it? The x value of that peak. Not the valley. We want the peak to be here to make it cosine. Yes. There's a hand. Yes. All right. There is a way to do this with a flip, but unless you need to make it have a flip, I wouldn't recommend it. So there can be a right answer that involves a flip, but I don't want to try to explain it. It'll get people really, really confused. Okay. So last thought. The period and the upshift. This one's pretty easy. How much did it shift up? Well, right here. And how far is that? 7.5. How many of you guys had 7.5 added to the end? Okay, good. Then the last thing is the period tells us the b term, and I got a formula for that. Period equals 2 pi over b. Then I can find that b term if I only knew its period. Well, its period comes from, how far is this from here to here? This distance, well, it's from 2 to 8, so it's a distance of 6. Is the period 6? No, that's half the distance for a full cycle. A full cycle needs to go the rest of the way, so the full period is 12. I know you're used to these being in like radians and stuff, but it's okay. It's just a number 12. Even if it was in radians and it was like 3 pi, it's just 3 times 3.14. You know, pi is just a number. So these always have just been numbers. All right, so this is a period of 12. So this 12 goes right here, and now I solve for the b that I kind of drew over and is right there. So final answer, b is 2 pi over 16, also known as 1 pi over 8. Uh-oh, 12. That's 12. My bad. The period was 12. Sorry. So now I'm going to solve it for b, and I get 2 pi over 12, which is pi over 6. There we go. Thank you for catching that. Whew. Now, I just want you to realize how powerful that is, though. You got 2 numbers, a high spot and a low spot. Do you get that in the real world really easily? Like, oh, the tide is going up and down. Like, the tide is at low tide. Now the tide's at high tide. You have a low number at a certain time, and you have a high number at a certain time, and then you have from low to high. Oh, I've got 2 points. Anytime you can give me 2 points, you can write an equation to keep getting that same cycle. It could be a stock graph. I've seen stocks. There's a website that tells you stocks that they have noticed are doing what's called channeling. And that means the stock price is going like this. Guess when's a good time to sell the stock? When it hits here. Guess when's a good time to buy it back again? Down here. And then you hold it until hopefully it goes up to here, and you sell it, and then it goes back down again to here, and then you buy more. And you can keep doing that. And there are people that do that. I did that for a while and made money on a bunch of stocks. But then the thing they don't mention to you, of course, is that every now and then you buy a stock that has been going like this, up, down, up, down, up, down, up, down, and then it goes, like goes down forever. And you had it here, and then it went so far past there, it can actually in one day go from like Bear Stearns did, $50 a share or so, down to zero overnight. If you happen to be holding it overnight, when the stock like went out of business, the company just went kaboom, then you can lose all the money that you had in it. So it's a good theory. I'm just saying it's not like a bulletproof. Hey, Mr. Server told us how to always make money in the stock market. No, if all of a sudden you're holding this stock and it goes out of business, it can be a really bad thing. But do you get how some people do follow stocks that channel like this, up and down and up and down? It's pretty powerful. If the stock does tend to go up and back and forth between two things, you can make consistent money on that as long as something terrible doesn't happen to the stock. Now, I could have got a surprise on the upside, too. You know, like all of a sudden the stock's going up, down, up, down, up, down, and all of a sudden, ooh, it turns out they invented the cure for cancer. Can you imagine if you own that one at the moment when they invent the cure for cancer? Holy crap, your stock goes up to 100 times its value overnight. And that does happen sometimes. They haven't cured cancer, but they've had huge breakthrough drugs where, oh my gosh, this drug actually lowers your cholesterol overnight, like by a lot. And holy cow, people that own it make a lot of money. Okay, so if I give you a low spot and a high spot, do you think you could get me an equation for it? Well, that was the goal. All right, so right now I want to show you what your homework is for tonight. I'm going to pause for a second while I pull it up. Okay, so your homework for tonight starts on this page. Can you guys tell me which page it is in your notes? 23? Good. Okay, so on page 23, you'll find this. And I have circled these 2 points for a reason. I want to help call out that there's a low spot and a high spot here. Can you see which one's which? The first one I circled here, what's that? That's the high spot. What's the highest that the temperature ever gets? 23.9 degrees Celsius. Do temperatures do that? Do they oscillate back and forth between a high temperature and a low temperature and a high? Yeah, they do that. Especially in a place like California, where oftentimes it's another 72 and sunny, and then the next day it's, you know, like it goes down overnight to maybe like, you know, 60 or something. And then the next day it's back up to 72 and sunny. And I've seen some places, especially if they're by an ocean, they tend to be consistent like that. They'll just, temperature will go up and down and up and down and up and down in a wave like that. Okay, so anyway, here's a high spot because the temperature is the highest that it gets. And here's the low spot. The temperature is the lowest that it got. And just, do we have to have all those other points in between? No. All that we really needed was a max and a min, a high spot and a low spot, just like last night's homework. Except we don't have pi's in there to make it more messy. So my x values will be easier to work with. So that's the point 18, 23.9. And this is the point 30. No, I got them backwards. Sorry. No, I had that right. 18, 23.9, sorry. And, all right, then we're down to our 12-minute warning here. And 30, 14.1. I had the thing so quiet that it was a 12-minute warning for a few minutes there. Okay, so I hope that you'd be able to make a little picture of this and go, okay, 18, 23 compared to 30, oh, that's the high spot. Okay, so that's the high spot. And then 30, 14.1, that's like the low spot. Maybe that's over here. Move this over a bit. And now I got a high spot and a low spot. What's the important thing? The line that runs down the middle of them. And I'm going to have a peak there and a valley there. And I realize, oh, it's been shifted. How far has it been shifted? The x value of that peak is how far it was shifted. And this peak is this one right here. And so the x value of that is 18. So you're going to have an 18 shift on this one. All right, there's another problem just like it underneath it. And then there's only one more for your homework for tonight. I'll pause while you show you. It's this one here. That's the last problem for homework for tonight. My intention is to grade the homework again tomorrow. I got the feeling some people had stopped doing your homework I get how that works, but you need to be disciplined about it even when I don't grade it. And we'll take 2 homework scores tomorrow. The one that we just did on the green sheet, and then the one that I'm intending to grade tomorrow. I think we'll have time because tomorrow is just all review day. Okay? Any other last questions? Yes. Okay. That's all I got for the video for today.